One method of solving quadratic equations is by completing the square. And by completing the square, what we're doing is we are creating a perfect square. I'm just going to illustrate a perfect square using pronumeral a. It's a bracket which is multiplied by itself. So it's x plus a times x plus a. Now if I expand this out, we end up with x squared plus ax plus another ax plus a squared. And if I collect the like terms together, we've got x squared plus 2ax plus a squared. So what we're aiming to do is represent our original quadratic equation in this form, and then we can write it as a perfect square. I'm just going to write down the original equation again. X squared plus 4x minus 21 equals 0. Now the first step is I'm going to move the number part onto the right, which means adding 21 to both sides of the equation. So we end up with x squared plus 4x equals 21. Now these two terms here are the first two terms in our expanded perfect square. So you can see that 2a is equal to 4. So 2a equals 4, a equals 2, and a squared that we need to find, therefore, is going to be 2 squared, which is 4. So the next step is to make the left-hand side exactly as the expanded perfect square. So we've got our x squared plus our 2ax term already, x squared plus 4x. What we need to add in is our a squared, which is 4. Now if we're adding 4 to the left-hand side of the equation, we must add it to the right-hand side as well in order to keep the equation balanced. Now I can represent the left-hand side as the perfect square. So my a is a value of 2, so I end up with x plus 2 squared equals 21 plus 4, which is 25. We can now continue to solve for x, so we're going to square root both sides. So we get x plus 2 is equal to plus or minus 5. We're going to subtract 2 from both sides to get x on its own. So we've got plus or minus 5 minus 2. And that gives us two solutions. X equals, we'll take the first one first, plus 5 minus 2 is 3. Or minus 5 minus 2 is minus 7. So there are our two solutions for x. And we have solved our quadratic by completing the square. I'm now going to show you a much more complicated example. So we're going to take 2x squared minus 4x minus 1 equals 0. Now in this case we have a coefficient on the x squared of 2. Now we need to get rid of that before we can actually complete the square, or part of it is getting rid of that. So we're going to divide through each term in the equation by this number. We're going to divide everything through by 2. So that will give us x squared minus 4x over 2 minus a half, and 0 divided by 2 is still 0. Now we follow the same procedure as before, and I'm just going to write out our formula for our expanded perfect square over on the right here so we can refer to it. So remember, the first thing is we're going to take our number term over onto the right. So we've got x squared minus, now 4 over 2 I'm just going to write as 2x is equal to plus 1/2. Now we're going to create this in the expanded perfect square form, where these are the first two terms, so therefore our 2a is equal to minus 2. So therefore our a is equal to minus 1, and a squared is equal to minus 1 times minus 1, which is plus 1. The a squared we're going to add to both sides. So we've got x squared minus 2x plus 1 equals a half plus 1. Now we can represent this as our perfect square, which remember was our x plus a all squared. So we've got x minus 1, which is our a, all squared, is equal to, and a half plus 1 I'm going to write as an improper fraction as 3 over 2. We can now proceed to solve it by square rooting both sides. So we get x minus 1 is equal to plus or minus the square root of 3 over 2. And finally, x is equal to, I'm going to add 1 onto both sides, so 1 plus or minus square root of 3 over 2. Now this is an irrational number, so rather than put it in the calculator and get an approximation, I'm going to leave it as a surd because that's more accurate. So we have our two solutions for x, 1 plus root 3 over 2 and 1 minus root 3 over 2, and we have solved our quadratic equation by completing the square.